All right, welcome to another video, Chem with Com. We're going to continue from our last lecture. This is going to be a continuation of measurements, prefixes, and dimensional analysis. Those are the chapters you could read through in the OpenStax book. This specific lecture is going to be prefixes and exponential notation. So yeah, let's get rolling. All right. Starting from here on out, your calculator is going to be very important. You're going to get a non-phone calculator ASAP. Practice with it during every lecture video and use the same one for the videos or the lectures, assignments, and exams. That way you're using them consistently, right? You're not changing back and forth or using your phone and other calculator. And get a non-phone scientific calculator. Scientific calculator, all right? These are some free online ones you could use for now till you get your calculator, but you need to have a physical one for the exams, right? So you could use any of these or just search online scientific calculators. All right, I'll use a couple in this video so you can see how it works. All right, unit prefixes and exponential notation. All right, so here are the prefixes. Femto, 10 to the negative 15. Pico, 10 to the 12th. Nano, 10 to the negative 9th. Sorry, pico is 10 to the negative 12th. Micro, 10 to the negative 6. Milli, 10 to the negative 3rd. Centi, 10 to the negative 2. Deci, 10 to the negative 1. Kilo, Mega, giga, tera, 10 to the 12th, terawatts. Okay, so they're all right here. I'll stop underlining stuff, but these are the symbols. The only one really weird is this one. This is a Greek mu. So we'll say the Greek mu, right? All right, but I really want to point out that unit prefixes, meaning there's going to be a prefix, and then a unit. And these prefixes can be used with any unit we have, right? So let's just point some out. Seconds, meters, grams, liters, moles, hertz, years, watts, liters, meters, right? You can use them with any unit. So seconds, whatever. I ran out of ideas already, right? But they're all right there. So again, it's the prefix, then the unit. The prefixes can work with any unit, right? And you're going to have these factors available. So either print this slide out or make your own, but you're going to use these a lot. So have these handy for when you need them. All right, exponential notation is used in prefixes, right? When using prefixes. So let's take a look here. This is exponential notation. 10 to the negative 15, right? And this is the decimal version or the, yes, standard notation. This is the exponential notation, exponential. This here is standard notation, standard. And again, in the previous video, we learned how to go back and forth between standard notation and exponential notation. And just to reiterate, this little 3 means you multiply 10 3 times. This 2 is 10 twice. This thing here is, this 1 just means 10. Anything raised to the 0 power is going to be 1. This is 10 to the negative 1. That means 1 over 10. 10 to the negative 3 means 1 over 10, but 3 times, right? Again, we did exponents before. Check out the spreadsheet and you can figure out where you can go back and learn more about this, right? All right. Prefixes are just words that mean numbers. And let's go back to our original thing and let me actually see if I can fix this on the fly here without messing up too much, or else I got to start over. We don't want that. Oops. All right, now let's correct it. All right. So prefixes are just words that mean numbers. Now I gotta fixing everything on the fly now. Just gonna move this over a bit so we know what's highlighted. All right. Are just words that mean numbers, right? Kilo means 10 to the third or 1,000 because it's 10 times 10 times 10. That equals 1,000, right? Those are all the same number. Kilo just means 10 to the third, right? That's why we could say 1.35 kilograms or 1.35 times 10 to the third grams, right? And again, 10 to the third is 10 to the 1 times 10 to the 1 times 10 to the 1, which is 1,000, or 10 times 10 times 10, which is 1,000. Because 10 to the 1 equals 10. That's why we could do either one of these. All right, another example, micro. Micro means 10 to the negative sixth, right? So 270 microliters is 270 times 10 to the negative 6 liters. Micro means 10 to the negative 6. And that's going to be 10 to the negative 1 times 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 10 to the negative 1 equals 0.000001. We move the decimal over basically 10, or sorry, 6 places, right? We have a 1 here. We went 1, 2, 3, 4, 5, and 6. So that's where the decimal is going to be 1, 2, 3, 4, 5, right? That's going to be our number. Again, go back to the previous lecture if you need to help going back and forth between decimal or standard notation and exponential notation. Here again, we're just showing the units that we learned last video. And again, any prefixes can be used with units, right? So again, we can have megameter or kilosecond or nanokelvin or picomole, right? Or gigaliter, right? It doesn't matter what it is. We could use any prefix with any units. It doesn't have to be a fixed thing, right? So we'll practice that too. Again, see these units are prefixes in red, units in blue. So again, any prefix can be used with any unit. So we could say femtometer or picomole, right? Or kilo, well, this already has it, kilogram, or gigaliter, right? It doesn't matter as long as you have a prefix in a unit, it's all good, right? It's just remember the prefixes are just names or words that mean numbers. Just like a dozen means 12, or a mole means 6.022 times 10 to the 23rd, right? But again, units and prefixes can all be used with each other. This is just to show you that here, right? Kilogram equals 10 to the third grams equals 1,000 grams. This word here is grams if something gets cut off right here. All right, 1 kiloliter, 10 to the third liters. 10 was 1,000 liters, right? 1 kilomole. And actually, this is also I messed this up earlier and I never changed it. Let's see, 1.35. Actually, no, I think let's see here. 1.357. Oh yeah, so no, sorry, this is all right. Um, Yeah, but again, just prefixes work with any unit. So make sure you know that they're interchangeable. And the more practice you do with these, the better they'll get. I know it's very confusing at first, but the more you use them, the better you're going to get at these. All right. So let's continue here. All right. So we did this again. Topic 2, subtopic 3, moles and exponential notation. This lets you move or go from standard notation, which is like standard notation, back and forth to exponential notation. So check those out. Get comfortable doing that because we're not going to use this video time to do that again. Right. All right. So let's do some practice problems. All right. So when you add exponents, you're going to convert all the numbers to the same power of 10. I'll show you how to do that here. Add the digits in term of numbers, and if appropriate, convert the digit term back to a number between 1 and 10 by adjusting the exponential term. All right, easiest way, put it in your calculator, but don't forget significant figures, right? So I'm going to use this way just to get us kind of moving in without having to learn more than we actually need to at this point in chemistry, right? So let's add this together. I like to add these on top of each other. So we're going to add 5.00 times 10 to the negative fifth, 3.00 times 10 to the negative third. The sig fig rule for addition, subtraction is use least amount, I'll write that out, of decimals in the problem. All right. For using their least amount of decimals, this looks like, right? This looks like 2 decimals each, right? But it's not, right? Let's convert one of these to significant, sorry, let's convert one of these to uh the same exponent. And let's just recap there. Let's start over here. It says convert all numbers to the same power of 10. So I need to either convert 10 to the negative 5 to 10 to the negative 3, or I can convert 10 to the negative 3 to 10 to the negative 5, right? I'm going to convert this one. Just you can do either one. I just chose this one. Let's check this out. This is how I'm going to do this. 5.00 times 10 to the negative 5. That's going to be the same as 5.00 times 10 to the negative 5. I just basically wrote the same number, right? What I'm going to do here is I'm going to bring my 10 to the negative 5 to the negative 3, right? And this is a greater number, right? So the value of 10 to the negative 5 went up. Sorry, let me redo this here. I'm going to say, I'm just going to put it down here, I guess. I'm going to leave this number the same, right? I'm going to say 10 to the negative 3, right? This number, what I did with this number is I went from negative 5 to negative 3, right? I went up in value for this side, right? Because I went from negative 5 to a negative 3. That value went up. That means on this side, I have to bring the value, I guess I'll do a different color just to kind of hopefully follow a little easier. I guess green maybe, right? I have to bring this value down If I went up on one side, I have to go down on the other side. So this is going to be, and I move over two, since I moved this number twice, this has to go down in value twice. So it's 0, oops, let's do red, 0.0500. All right, so now let's do the math. I got 0.0500 times 10 to the negative third plus 3.00 times 10 to the negative third. All right, so now we're going to use decimals. Here I have 4 decimal places. Here I have 2 decimal places. So our answer should be 2 decimal places. And this is going to be 3.0500 times 10 to the negative third. 2 decimal places, it's going to be 3.05 times 10 to the negative. Here we are. I think the book did it the other way. So they changed 10 to the negative 3 to 10 to the negative 5. So you can do either one. All right, let's try subtraction, right? You could have done this one. Yeah, we'll do the subtraction next on the calculator, right? All right. So again, convert everything to the same number of 10. Let's try this. Subtract 4.0 from, sorry, 10 to the negative 7th from 5.0 times 10 to the negative 6th minus 4.0 times 10 to the negative 7th. We're going to have to change these decimals. Let's change the 7 to 6. I'm going to do that what I did earlier. 4.0 times 10 to the negative 7. I'm going to rewrite the number and here. So if I'm going to bring this number up to 10 to the negative 6, right? Because negative 6 is greater than negative 7. So what I did is I raised the value of this side here by one number, right? So I raised it by one number. So what I have to do on the left side is I have to lower it by one decimal. So that's going to be 0.40. So let's look at this again. 5.0 times 10 to the negative 6 minus 0.40 times 10 to the negative 6. This is one decimal place. This is 2 decimal places. So our answer should be 2 decimal places because of our rule. Well, let's take a look here. So now let's use the calculator. So again, you're going to be using one of these. It's going to look like this or look like this. Or I recommend, again, just getting your calculator so you could start practicing early. So it's 5.0 times 10 to the negative 6. Now, every time you have an exponent, I strongly recommend using these brackets, right? Because it tells us, the brackets tell us this is one number, this is the second number, right? So let's do that. Let's see here if I can see this. So 5.0 times, and you see this little 10 to the, I'm going to hit the second button, times 10 to the, and this here is the negative sign. Here's minus, here's negative. Negative 6. I'm going to use the arrow to go a little further and then do a close parentheses. I'm going to use the minus sign here. Minus, and then parentheses or brackets, point. Let's go back one. 0 point, oops. Let's see. I guess I have to clear it that way. Let's do this again. All right. So it's 0.40. So 0.40 times, and then again, we're going to hit the second button with this 10 to the x here. That's the blue one. To the negative 6. The arrow to move over, and then the close parentheses. And we're going to hit enter. And it's 4.6 times 10 to the negative 6. Let's try that. So this is going to be 4.6 times 10 to the negative 6. But you saw a little earlier, or right here, 4.6. This is a capital little e, and it says negative 6. This part here is e, this capital E, capital little e equals 10, right? Raised to the something. So that's what this little e means. So it's the same number times 10 to the negative 6. These are the same number. Let me put a proper arrow here. Oh, sorry, and I actually made a mistake here. All right, we should have one decimal place in the answer, right? Because this is one decimal, two decimal. We want to use the least amount of decimals, so it should be one decimal, right? So these here are the same number. That's why you want to use the calculator you're going to use on the exam really early so that you get practice at it, right? All right, so 4.6 small uppercase e negative 6 is the same as 4.6 times 10 to the negative 6. All right, now let's do multiplication. Let me just try this out here. So here, you just straight up put it in your calculator. Let's get some practice, but let's do this first. Let's take a look. This here has 2 sig figs. Here, this has 2 sig figs. So our answer, 2 sig figs. All right, let's do this here. 4.2 times 10 to the negative 8. I'm going to use a different one now just to show you. So 4.2 times 10, and then we're going to press this button here. Oops, sorry. Let's go back one. This button here, because we want to make that a, on this calculator, it looks like minus and negative are the same. So we'll say negative 8. And then we're going to do the close. Oops. We're going to move the arrow over 1, do the close parentheses, times 2.0 times 10 to the third. Again, I'm going to do open parentheses, 2.0 times 10 to the negative third, arrow, close parentheses, right? Oh, it's just third. Let me delete that negative. So it's 4.2 times 10 to the negative 8 times 2.0 times 10 to the third. We're going to hit enter, and it's going to be 8.4 times 10 to the negative fifth, right? 8.4 times 10 to the negative fifth. 8.4 times 10 to the negative fifth. And we already have 2 sig figs. 2 sig figs, so we're done. This is the answer. 8.4 times 10 to the negative 5. All right. Let's do now a division. Divide 3.6 times 10 to the negative fifth by 6.0 times 10 to the negative fourth. Boom. Count sig figs. Two sig figs. Two sig figs. Remember, you're going to use the least amount of sig figs, but since there's only two sig figs in both, and swear, answer is going to be in two sig figs. So let's just put that in our calculator. We'll go back to the other calculator. 3.6 times 10 to the negative 5. But remember, use brackets. Use brackets, use brackets, use brackets. Right? And I'm going to, right here, use brackets on all exponential notation calculations. Calculations. All right, let's try it. 3.6 times 10 to the negative 5. We'll go back here. Clear this one. 3, oops, already forgot. 3.6 times this one, 10 to the negative, what we were, 10 to the negative 5. Arrow to move over one, then close parentheses, divided by, open parentheses, 6.0 times second, and then 10 to the negative 4. Arrow, and then close parentheses, and then enter. So I got 0.06, and we'll write that a different way, but let's take a look here. 0.06, right? But we need two sig figs, so we're going to add another. Because this is only one sig fig. If you need sig fig stuff, go back to the first topic. Two sig figs is 0.060. But they got this number. Let's check that out, right? Again, if you need to convert back and forth to decimal, we're gonna, there was previous chapters on that, but let's take a look here. This is gonna be 0, sorry. We're gonna move this over 2, 1, 2, so that it becomes 6.0 times 10 to the 2. But because this number was less than 1, it should be negative exponent, right? So it's going to be -2. Again, other video will get you back, let you convert back and forth from standard to exponential notation. All right, well, that's it. The calculator, post questions on Discord, and we'll take care of you. All right, I'll see y'all next time. Thank you very much.